For proportional relationships, we can write equations, and we can solve equations, so let's do both. As a reminder, a proportional relationship between x and y can be modeled by the equation y equals kx. In this equation, k is the constant ratio of y to x. It is called the constant of proportionality. To find k, you can use the equation k equals y divided by x. On to the examples. Tom is participating in a fun run to raise money for the West Side Children's Hospital. The run is held at Tom's high school track. The more laps Tom runs around the track, the more money he raises for the hospital. There's a proportional relationship between the number of laps Tom runs, x, and the amount of money he raises for the hospital in dollars, y. If Tom runs 1 lap, he raises $5. So first, we're asked to write an equation for the relationship between x and y. There's a proportional relationship between the number of laps Tom runs, x, and the amount of money he raises for the hospital, y. So the equation should be in the form y equals kx. To write the equation for this relationship, we have to find k. So let's look at this sentence. If Tom runs 1 lap, he raises $5. This tells us that when the x value is 1, the y value is 5. We can use this to calculate k, the ratio of y to x. Since k equals y divided by x, we have k equals 5 divided by 1, which equals 5. We can plug k equals 5 into the equation y equals kx to find the equation for this relationship. The relationship is represented by y equals 5x. Great! First part done. Next, how much money does Tom raise if he runs 2 laps? Well, we just wrote the equation for the proportional relationship, so let's use that equation to find how much money Tom raises if he runs 2 laps. X represents the number of laps Tom runs, and y represents the amount of money he raises. So let's plug in 2 for x and solve for y. Y equals 5 times 2, which equals 10. Tom raises $10 if he runs 2 laps. And finally, how many laps does Tom need to run to raise $20? Let's use that equation again. X represents the number of laps Tom runs, and y represents the amount of money he raises for the hospital. So we can plug 20 in for y and solve for x. 20 equals 5x. To solve for x, we divide both sides by 5, which gives us 4 equals x. Tom needs to run 4 laps to raise $20. Let's try another. Winston is throwing a pool party to kick off the summer. His pool is empty, so he starts filling it with water from a garden hose. There is a proportional relationship between the time Winston has been filling up the pool, in minutes, x, and the volume of water in the pool, in gallons, y. The pool has 44 gallons of water in it after 4 minutes. Write the equation for the relationship between x and y. Because there is a proportional relationship between the time Winston has been filling up the pool and the volume of water in the pool, the equation can be written in the form y equals kx. So let's find k. The pool has 44 gallons of water in it after 4 minutes. So when the x value is 4, the y value is 44. K equals y divided by x equals 44 divided by 4, which equals 11. We can plug k equals 11 into the equation y equals kx. So y equals 11x shows the relationship between x and y. On to the next one. How many gallons of water does the pool have in it after 7 minutes? Let's use the equation. X represents the time Winston has been filling up the pool, in minutes, and y represents the total volume of the pool in gallons. So plug in 7 for x and solve for y. Y equals 11 times 7, which equals 77. The pool has 77 gallons of water in it after 7 minutes. After how many minutes does the pool have 88 gallons of water in it? This time we have y and we're looking for x. So plug 88 in for y and solve for x. 88 equals 11x. Dividing both sides by 11, we have 8 equals x. So after 8 minutes, the pool has 88 gallons of water in it. Writing equations, solving problems, now you can handle proportional relationships.